Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Carl Carlson.
And Fred Schenkelberg. Hey, Carl.
Hey, Fred. I've been working on part of my practice that I really enjoy is the questions and answers we get from people. And I got a question recently about that relates to key characteristics. And it elicited a really good email exchange and that type of thing. And I thought it'd be fun to explore. We've talked about it years past, but not in recent years. And I think there's more and more rationale for understanding what the key characteristics are in any product or process and how those are used to improve products. And I just wanted to chat with you in general about the subject.
Well, you're going to have to refresh me what you mean by key characteristics. Is this like if it's a phone, it should actually connect to the internet? Although I don't know, I haven't used my phone much to actually make phone calls, so I don't think that's a key characteristic anymore.
No, let me describe it. It starts with the concept of product characteristics or process characteristics. So let's just get into what characteristics are in terms of design. They're features or attributes or even properties of a part. They could be things like color, weight, dimensions, surface finish, hardness. They could be things like EMI. There's certain measurements of EMI. They're basically measurable characteristics of a product.
Does that include the features, like a phone should actually do a two-way voice communication?
Well, if you get down to the characteristics of the voice communication, like
clear
what makes
and
for good
lag
yes.
and stuff like that.
Yeah, things that can be measured.
Okay.
Then those become characteristics. And then this whole subject of prioritization, and we've been in this, we've talked about this so often, how important it is to focus on the vital few rather than the trivial many. And it even in our R&M management tutorials that we've done and that now Chris and I are doing, that the whole concept of narrowing down to the vital few, you get into this concept of key characteristics, or what we could call the vital few characteristics that are most important. And that's what we mean by it. What are the product characteristics? They're measurable. They are they can be part of requirements. They affect the safety or key performance. So they're very specific in some companies, and there's a nuanced difference, which we could get into, but some companies use the phrase CTQ, critical to quality, and others use the phrase key characteristic or significant characteristic. And they're very similar. There could be some very small differences between those terms, but the concept is the same.
Yeah, no, I upset a quality manager once because they had their CTQs or CTQs, and I came up with CTRs, critical to reliability.
Oh, no.
Yeah, so I had my own numbering system and everything else.
There you go again, Fred. And so if you can identify these vital few key characteristics, and in the old world, they would show up on drawings as key with little symbols like upside down triangles or whatever. And in the new world, of course, they're identified in some digital way. That, from a product standpoint, that key characteristic gets passed on to the manufacturing plant or to the supplier or to the assembly.
In theory, it should.
Yes. And then their job is to achieve those. And so they don't have to then do SPC on everything. They don't have to then, they can do due diligence on everything. But certain things are more important than others,
right? Because
they affect safety or the complete performance, like shutdown. And so those then become heightened in the manufacturing process or the process control plant. So it's a big subject, and I just wanted to kind of explore it with you a little bit to see how this affects reliability. Like if you do a good job of it, does it improve the reliability of products?
I mean, it's to a large extent, this is how I got into reliability, is that when I was a manufacturing engineer, I mean, one truism I came out of that process is it's always the designer's fault. But the actuality is they can create a beautiful design, but if we can't manufacture it, we're going to pay for it in yield loss, but also it's just going to be a inappropriately functioning product when it gets to the field. And so this idea of going back to we didn't call it CT, critical to quality. It was like, we've got 57 things we can play with and monitor and track as we make this product. Which ones do I need to pay attention to? Which ones matter? And luckily, the design team was in the same building and sat, basically in the same aisle, a bunch of cubicles. We all sat together, and it wasn't a very big team. So we ended up with all these discussions about the chemical properties and the behaviors and the mixing and all these things that went into this product we were making, and which ones were important or not. And if we didn't know, if they didn't know, we go off and run experiments, similar to what we were talking about before. Is, well, what does matter? Let's go figure this out. Today, though, very few people have manufacturing on their own site, and the designers are in Australia and software teams in Russia, and the factory is strung out over 47 factories. I mean, cars today, is any of them, there's no Ford plants where they're bringing in raw material and out comes a car. So this communication vehicle becomes more important, but it also becomes a balance between what's the priority for your suppliers versus what's your priority, and how do you communicate these key characteristics. And it's important to both of us.
Yeah, you're presenting the challenge in all of this is that it's more, as you say, it's more important than ever because of the distance where the manufacturing plant might be overseas. It's more important than ever to communicate the vital few characteristics that absolutely must be achieved. And yet it's harder than ever because of the distance and the language and
the difference in priorities. I've run into it where you hand off and you say, these are the critical things on the drawing. And then I get only that. Everything else falls off the plate and is just horrible. It's not even due diligence on it. Well, you told us to pay attention to these. Not at the exception of everything else. And so that's one lesson. Right. Another one is, okay, it's important. So they squint their eyes when they look at the drawing, but nothing else happens. And right. No, you actually have to make measurements. And you didn't say that. Okay.
Oh no.
But it's what they're doing. A manufacturer versus a designer. In the end of the day, you would think we have the same goal. But I've run into situation after situation where you hire a contract manufacturer, you send over the drawings, you fly over and have a bunch of meetings, you all go to lunch, and they're looking for, how do we maximize margin and reduce yield loss? Versus the design team is like, well, you just need to make it according to the drawing. And those are not always compatible.
Right.
And so I could tell you, I want you to watch this thing, but I'm going to change the material so that tolerance doesn't make any sense anymore. And I'm like, okay, this is a problem.
Indeed. My first run-in with I have two stories that are floating around in my head. My first run-in with key characteristics was back in the mid-'80s when I was a supervisor of a door testing lab as part of Fisher Body. Mm-hmm. And we would open the doors and slam them. And, we wouldn't do it. The machines would do it and run the windows up and down and that type of thing. And we had one of the things that we tested, and we tested a lot of the components of the doors, was the door impact beam. And so inside between the sheet metal of the outer portion of the door and the inner panel is this impact beam that protects you from a crash. Mm-hmm. And the safety regulations are understandably pretty high on door impact beams. And so we tested them year after year after year. A new program came out, buy a bunch of door impact beams, put one end of the beam and the other end of the beam on these little fixtures, and then a machine pushed down in the center, and you do a force deflection curve to make sure that it's strong enough that it meets requirements. We would test that. It's not cheap to do that and get it to the right confidence levels and etc.
Well, were these beams different materials, different sizes, different configurations from
Each
car
year
to car?
there was a somewhat different configuration, like they might be experimenting with the materials, and they might be experimenting with the cross section, the weight, things like that. So, however, we came to know by talking to the analysts and things, we came to learn that there were really two characteristics that if you knew them and if you had the right model, you could simulate the force deflection curve. And those characteristics were the material composition and the cross-sectional area.
Right.
And once you knew those, you could literally calculate the force deflection. And so what we did is we went about a year doing it both ways until we were confident that the models worked. And then we stopped doing the physical testing once we were confident that the models worked. And sure enough, as long as we kept the diameter or the geometry according to specification within ranges, and we kept the material composition within ranges, we would get the performance of that impact beam.
Right.
That was my first run-in, and it sort of opened my eyes that there's something to this subject.
Oh, yeah. I've run into it a number of times, and what's funny, though, is that at times the design team will fixate on something that they swear is the most critical thing. We get it in manufacturing, and I ran into this, and it's like, well, that's the easiest thing to do. We got a lot of margin on that. So if that's critical, that's cool. All right, we can show that we've got this, CPK of 12 or something like that. We can handle that. And then we'd screw up other stuff that we didn't know about. So I think the key characteristics is the process of identifying them is not a trivial process. I think it's the balance of, well, where are all the trade-offs? And I ran into one designer that said, well, everything's important. You can't ignore anything. I was like, okay.
No,
which one,
not...
if I got $1 and I got it invested in doing this, he says, well, if there's 100 things, each gets a penny. I says, well, then I won't be able to give you much of any useful information on any of them. But if I mess around with just this parameter, that's critical. You got it. What if I mess around with that? Well, that's got a lot of tolerance. And then it turned out to be this discussion and set of experiments going, this is how our part of the process works and what doesn't work and what we can and can't control. And it turned into a series of experiments. We learned a lot, like you paid attention to what was important about those beams and sorted it out. And at first it was probably, there's 57 critical things on that beam. And you narrowed it down to here's two that really make a difference. It's not always obvious. It is. That's my point.
Let me share something about FMEA that I found very useful. And I didn't learn this until the last 7 or 8 years. The cause in an FMEA, by definition, cause is the reason for the failure mode, usually expressed as a potential design deficiency. So you might get like take a bicycle brake pad, and the brake pad, so take the bicycle brake pad. So the brake pad, maybe it doesn't perform the way it needs to. Maybe a cause has to do with the material of the brake pad, that it doesn't
becomes Teflon.
Yes, exactly.
It's very slippery.
and or you could have the brake cable, and maybe the brake cable breaks because of corrosion. But it isn't just corrosion; it's because you've got material was selected that's corrodable.
Right.
And so you have a potential design deficiency, and that's in the cause column of an FMEA. And what I found is very often, if you do the FMEA properly, you'll get two things that relate to CTQs or critical characteristics. One is the cause helps you get its input to the product characteristic that is most critical. And the second thing is the severity and occurrence will guide you into the vital few. And so you can have a company policy that says, with this set of severity and occurrence, we're going to make something a key characteristic, and we're going to get that information, at least the input is from the cause column in the FMEA. And that's been a real eye-opener to me. It's not automatic. You have to know what you're doing. You got to get the FMEA right. But it does help to get to that key characteristic.
The way you're describing that makes me think of, and I I think it actually got dropped from the body of knowledge and quality and reliability out of ASQ, is remember the House of Quality?
Oh, I do.
Right? And they actually used the term key characteristic.
That's right.
Right?
They had an importance rating. You're right.
So it's very similar to that, but what wasn't clear to me is, well, what is a key characteristic? And we pull it from the design requirements document. It has to make phone calls. It has to weigh this much. These are all the things. And these are the ones that are in the prioritization off of that the first house was on what's important to the customer and translating what they want versus what we're specifying. And then those specifications then got translated as input into the next step, the manufacturing team. And then key characteristics were manufacturing settings and tolerancing and stuff like that, and so on. It would cascade down. Having learned that process and experimenting with it way back when, I have never seen it since, other than in textbooks. I've never seen anybody actually ever use it.
We have a column now in the SAJ 1739, the one that came out in January of this year. There's a column on significant product characteristics in the DFMEA, significant process characteristics. It's well defined in the standard, but in essence, it's what I talked about as characteristic. The key part of it says it's the significant, unique product-related characteristics that can affect safety, regulatory compliance, or functional performance. So you're basically prioritizing the characteristics. And company policy sets what is key.
Right.
It's not automatic, but it's the vital few characteristics that affect safety and performance. And then those, they have to be CTQ, they have to be measurable, and they have to be outputs of the design. So there's certain definitions. And I like to use the FMEA, providing I'm doing an FMEA.
Mm-hmm.
In other words, I don't want to automatically do FMEAs and everything, but I like to use the FMEA to, in addition to everything else it can do, to also recommend key characteristics to the team. And then those go to the manufacturing.
Well, I agree that it's a part of it, but it's so dependent on what team you got together. If you don't have a manufacturing rep, right, or anybody knowledgeable with how this particular assembly process and tolerancing, it's got to be a live FMEA and the right team in asking the right questions. See our last, or listen to our last podcast. But the idea is that I think that's what not that I ever want people to go spend the time to do the House of Quality thing, because I think it's not being used for all kinds of reasons, but it had the concept is that the design is not the end goal. The end goal is creating a product that's functional and works for your customers and delights them, does all these other happy stuff. But it involves the design, its interaction with manufacturing, the interaction with suppliers of materials we're putting into the manufacturing, and all the way down. I mean, and we learned it the hard way in reliability, is that we had there was a scenario that affected the electronics industry, is that the black encapsulant that goes on ASICs, on silicon and all kinds of other devices, has a flame retardant in it. And if that flame retardant isn't the right size, it falls off. It falls out. And it's very, very corrosive. And it turned out that a mesh that guided the sizing of this raw material was like 6 steps away from the ones that were building and selling the ASICs, right? It was a component that went into a mix that went into an epoxy that went into this process to make ASICs. And it was, there's no way we would ever call that out as a key characteristic, as the grain size of this particular flame retardant material has to be within this tolerance. So the hard part for me is that we regularly get surprised by things that we aren't even aware of.
Well, and there is the humility in the process, because there's a lessons learned where you'll go and field a product, then you discover
we miss something.
You get most of it. Yeah, I want to say, hopefully you get most of it right before launch. But in all humility, there are times when you don't, and you've missed something, like you say. But then that becomes the lesson learned that goes back into the next generation. and hopefully you get better and better, because key characteristics don't all come from the FMEA, just some of them. Some of them come from experience.
Right. Well, the hard part is that if you're always chasing what you did wrong the last time, you're going to always be reactive.
Yes.
The other scenario is, and I've ran into a program manager that goes, well, we have to go 4 levels deep on every characteristic for every material we use. And it is an enormity he was basically saying, we can't afford to be surprised like this anymore. And it was true. It was a pretty bad problem. And not this flame retardant one, but a different issue. And he was saying, I want all the procurement engineers to go 2 levels or 3 levels down to all of the raw materials and what's what's important, what's not, what tolerancing on it. And so there was a whole lot of money spent on a many trivial few.
Well, and let's state to people what the downside is, and I'll go back to you could have a big recall or huge field issue that costs millions and millions of dollars or even more. Mm-hmm. And then I've seen, true story, I won't go into names, but I've seen where a company then reacts and says, okay, we're going to do FMEAs on everything. Mm-hmm. We're going to go deep out from the system all the way down to the part level, and we're not going to miss one thing, and this is never going to happen again. The problem is, Fred, and I know you know this, is that you're going to then miss the forest for the trees. Yep. Because you're going to consume all your resources, and then you're going to miss the big things on the next next thing that happens. Yep. And that is not considered. So I would rather do fewer FMEAs really well than lots of FMEAs on everything but done poorly.
Yep. No, I totally agree. It is striking the right balance. And yes, we can learn things from our past mistakes and generalize them as lessons learned. I think one of my favorite ones is the ceramic capacitors. They break. They're pieces of glass. And if you treat them poorly, or they will break and then they won't function for you, and it causes problems. Even though they're a fraction of a cent component, there's gazillions of them on all electronics circuitry, they can cause problems if you don't pay attention to some basic handling, basic treatment of them, because they're just little pieces of glass that will break. Right. And so to me, a lot of what we do in reliability work is understanding the failure mechanisms and what are the factors that contribute to it. Whether it's a bike cable that if we pick a bare metal that's prone to corrosion just in oxygen, not even with moisture, we're kind of asking for trouble for a product that's used outdoors. It's just going to be a problem. But understanding the failure mechanisms, I think for me, helps us to identify as another source of input into the key characteristics is, well, if we don't get the coding right, then we have this problem. So the coding is a candidate for a key characteristic, in my opinion. This is the way I think of it.
Absolutely. And in the example I gave on the brake cable where there's a corrosion problem, it's the same kind of thing. You've got to have the material that is what's the word, robust, right, to corrosion, if that is indeed the underlying root cause of the problem.
Well, then you can look at, is it rubbing? Is that removal of the outer layer? Does that cause corrosion to occur? Or is it some other? But to me, and I'm looking at it really from just a reliability point of view, because it affects safety and functional performance and everything else, but it spans the entire life cycle and all of the supply chain. Because if that doesn't work, right, it could be from somebody's supplier, but now we know to go look for that. But I tend to focus it on how would this not work? And it's a big function of what the FMEA is about, right? This is a function. How would that not work? Well, if this cable is corrodable and it won't have the tensile strength anymore, well, then that's a failure. Let's sort out where that comes from. I think that logic is something to keep in mind.
Absolutely. If you're listening to this podcast and you have some stories to tell, ideas about how key characteristics can be used, or questions for anybody on our team, Fred, myself, or anybody else at Ascendo, please get in touch with us.
Yeah, and you can do that over at accendoreliability.com/go/SOR. And there you can leave us a voice message with the speak pipe widget, or you can leave us a written message. You can find Carl and I and the other hosts of the show on LinkedIn and or on our About pages on the site. Plenty of ways for you to join the conversation.
Well, that was a fun conversation.
Well, we'll probably have to revisit this again sooner than later.
Again, revisited again.
That's right. Well, let's see what kind of questions we get, because I think there's many things that we went through pretty quickly. And I know I've got a handful of questions. So maybe I'll send some in. I'll create an account on TikTok or something.
Use the speak pipe.
Oh, yeah. No, that'd be way cool. All right. Well, thanks, Carl. We'll talk to you again soon.
Talk to you soon. Bye-bye.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.